Hi, this is Ben Thompson from the App Connect Enterprise development team, and on today's recording, which should last us about 20 minutes, I'm going to do 5 demonstrations showcasing some of the latest features and patterns to be added to our App Connect for Healthcare version 5 offering, which was released a few weeks ago at the end of March. All of these demos are using a standard Windows 10 system onto which I've installed the App Connect for Healthcare offering, which runs on top of App Connect Enterprise version 11.008. The first scenario we're going to dive into is the Healthcare Resources pattern, which helps a developer quickly get productive by providing access to a set of data models and example test data for some very common healthcare standards. So I'm in the toolkit here, and you'll notice that I've already defined an integration node. We're going to use that for doing some deploys later on. But we're going to begin life up here in the Patterns Explorer, where you'll notice that there's a healthcare category for all of the patterns that are provided with the App Connect for Healthcare deliverable. And one of them in particular that we're going to dive into is the Healthcare Resources pattern. But as I scroll down this bar here, you'll see that there is a short blurb and a picture, an architectural picture to describe the majority of these patterns so that you can understand in basic terms what they offer before you get there. With the Healthcare Resources pattern, you'll see a list here of the various things that you can import. So this is providing you a set of DFGL models, a set of other XML schemas and JSON schemas that can be imported here. I'm going to create an instance of this pattern, and then from the simple dialog here, I can select which kinds of resources I'd like to be imported. So in this example, we're going to choose FHIR and HL7 test messages, and then we're also going to create an example of the HL7 DFGL library because that's going to be useful to us in the thing we're going to demo next. So here I'm choosing to put that into a static library, and you can see I've ended up with 3 projects here, the DFGL library itself, and then a couple of independent projects with the test data. So having imported those resources, we're going to try and use those message models with some test data. We're going to pair together both the test data and the message model that we've imported. So if I expand here the HL7 directory first, we'll look at the 2.7 version of the standard, and it's the classic one that everybody always reaches for, the ADT-A01. And we've got this test data. At the moment, it's just a text file. This is just a file on disk that's within our Eclipse workspace. And you'll note that there's a whole variety of different chapters that could be used to parse that data. We're going to try a generic HL7 schema here. And the reason to pick this one is it would work with any HL7 piece of data that you want to fire in. If we navigate down here, you'll see that there's a choice structure that has embedded within it all of the potential segments that are provided with the model. So any one of these could be used regardless of the data coming in. If we just highlight that top level message and then click the button to test parse this model, we're going to have another dialog open for us. It gives us the opportunity to select the test data that I want to attempt to use against this model. So here I'm going to browse to that local file that we just highlighted with the test data in it, all within the same local workspace. At this stage, I don't have to deploy anything to the runtime. This is just using the capability directly within the toolkit. And it's asking me if I want to change perspective to the DFGL test perspective. We're going to say yes to that answer. And after a few seconds, the parse completes, and it shows us where the data has, how the data has been interpreted. So this is showing not just the data, but the markup in the bottom panel here, which demonstrates where the various delimiters have occurred within the message. You can see we've got a different color for the 3-letter identifiers for each of the segments. And we can also compare that to the tree view that's in the top right corner. So if we expand some of these sections of the tree view, you can see how they've been interpreted. We've got the data types for each of the fields, and then within the subfields of there, we also have the values that have come through. So in a very simple fashion, we've shown that we can take test data, parse it against the HL7 model that's provided out of the box with literally a few clicks of the mouse. So pretty straightforward, so far so good. Now we're going to move to one of the newer patterns to explore how we do mappings or transformation between HL7 and FHIR. So this is an entirely new pattern. Again, it builds on the capabilities we've already shown. So this is going to reuse the same DFGL models. And we support, at the moment, these 3 different resources. We've got allergy intolerance, observation, and patience. So I'm going to create a new pattern instance here. I'll give it the name demo2. And the pattern parameters that I'm being asked for here basically control the inputs and the outputs for the flow. So the first one of these is defining on the local host the port number that's going to be used by our HL7 DFGL input node. On the output side, I've got a number of directories here. Depending on having done the mapping, I'm then going to validate the message to check that it's all good. I'm going to choose to do that with the new FHIR validate node. And as a result, the output might end up in one or more different directories. So we're going to click the generate button here. This is going to create an example flow. That flow has underneath it several different Java snippets that we use, and it also has some ESQL as well. So we're going to look into the detail of what that flow looks like and how it handles that transformation. So in moving from HL7 to FHIR, the first and most obvious thing is the input comes through a DFGL input node. The next after that, we have this flow order. So there's going to be two different branches of execution here. The first one is going to create an acknowledgement message and then send that acknowledgement back to the original requesting application. So this is just to say, yes, we received the HL7 successfully. The second branch is to then execute a transformation. So this compute node has been generated for us. And the top level eSQL here is actually very straightforward. And it's specifically set up for this example of the three particular resources, but you might well change the code that I'm showing here to something of your own choosing. The first thing this code does is it examines the input message to see which segments we have. So it's going to loop over all the segments in the input and count up how many of each we have. And based on that, it's then going to go into one of three different sections of code. So this is looking to see if we have the right number of segments in order to do a mapping to the observation resource. We've got a similar section of code after that that does some checks to see if we're in a position to map the patient resource, and then a final section for allergy and tolerance. If none of those are satisfied, we end up in the code down the very bottom here. And this is basically just telling us which particular segments we did receive so that we can write that out to the user so they understand why we didn't complete any of the three transformations that are offered. And those three paths all relate to some procedures that have been generated for us. So you'll notice here this is doing an HL7 to FHIR observation. So this is doing the transform itself. And this is taking fields from that input HL7 structure to create the output JSON structure for FHIR observation. And then depending on how that went, we will either say we had the wrong segments available and go out down that file path, or we'll then validate the file that we've produced and we'll then write those out to a directory. So there shouldn't be any situation where that has really kind of gone wrong with the wrong data, and we would always expect that to work. But just on the off chance there's been a problem there, we've got the FHIR validate node in as well, just to show that capability. This little warning that's popped up there is saying that I'm about to deploy this flow that uses one of those subflow user-defined nodes that I mentioned. So being a subflow user-defined node, we have a particular style of file that's used within the bar file. And that's what I then deploy into the runtime. So we've now deployed this flow down there. It's in a position to be tested. And we're going to test it out. I think in this example, if I'm remembering my demo correctly, we're actually going to try this out using another capability of the App Connect for Healthcare, which is to create an example of our inbuilt tester. So we have an HL7 test application that's offered as part of the toolkit capabilities, and that requires an Eclipse container. So you could use any one of your containers. Probably simplest to go with an application container, just so that you save your test data away with the flow that you're intending to invoke. And then having selected that, it's given us the bones of this testing utility. So this healthcare sender is going to take some data from us to fire in through that flow. So this is going to make a socket connection into that HL7 DFGL input node. And we're going to send it, first of all, this example of an AO1. Now, this AO1 message is not an obs. It doesn't have the right segments in it for any one of the messages that I just described. So this is going to show an error path, first of all, and then we're going to show a good path after that with the real test data. So what this is going to send in then is this AO1, and the first thing that happens is we get an acknowledgement back. So it's successfully received the HL7 data, but that doesn't mean to say that we've successfully transformed it into a FHIR message. So what we're then going to go and look at is what's happened on the file system. Having passed in that message, we'd expect it to end up in the wrong segments directory for the output. So I've got some directories here which were created ahead of time to make the demo run smoothly. So if I go into this output directory, we have both a valid folder and a wrong segments. If we go into the wrong segments folder, we've generated a simple JSON message, which basically tells you what segments were received and the fact that they didn't meet the requirements to do any one of those three transformations that I was talking about. So this is showing that we've got an NK1 there with the value 1. We didn't have the OBR, we didn't have the ORC, etc. So you've got a fair number of zeros passed through there, and you have a PV1 segment at the end there. So a couple of the right segments, but not the right total set in order to do any one of those three useful transformations. So rather than the ADTA01, what we also provide with that same generated application is 3 pieces of test data which show the good paths. So going into the observation one here, if I copy that data out from the file and put that into my testing utility here instead, so I'm going to get rid of the ADTA01 here, put that one instead, then hopefully we'll have a little bit more luck invoking that flow. So I'm going to go send first of all. As before, we got an acknowledgement back, which is an awfully good start. But this time, if we go to the file system and look for the output, we should see things have gone down the other route and have gone into the output valid directory. And here we have the FHIR resource that's been generated. So this is a JSON form of FHIR that we're aiming for here. I think I'm just going to copy this out of the code editor to look at it in a little bit of a nicer fashion. I think we did that. If I just yes, I think I'm going to a web browser here, so I'm just going to go to the JSON lint. You can use your own browser or your own editor of choice, of course. This is just a very quick way to validate that JSON is a valid structure. And as we scroll on down through it, you'll see that there's a set of fields here that originated from the input message that have then been copied through into the output. So very trivial example, if you like, but again, even to get as far as we did in that quick example, that would have taken many hours of effort to go to the website, look at what the transformation is, and to do a similar thing. So moving on, in the interest of time, next one that we've got here is not the HL7 to FHIR pattern, but the HL7 generate example data pattern. No, so FHIR generate example data pattern, sorry. So this is, rather than mapping from HL7 coming in, this is going to create some FHIR resources from scratch for us. Again, like all of these patterns, we start by creating a pattern instance. And this particular new pattern has a few options here. We can decide whether we want to use a shared library or a static library for the resources that we generate. The most interesting part here is probably this last one. If I expand this to full size, you'll see here a list of all of the FHIR resources that are provided as part of the standard and as part of the pattern. So we can select them all, deselect them all, we can pick out particular ones. And the purpose of this is to say, for these particular FHIR resources, please generate me the code that would be required in order to create one of any of those resources from scratch. So in this particular example, I think we start by selecting all of those. And then what this is going to do is generate essentially a whole range of procedures that have populated data already set within them, again, based on the sample data that's available on the FHIR website. So we've mined from the FHIR standard all of the examples for each one of those different resources. And then based on those examples, we generate code which will create them for you within a flow. So you can see here that we've created an application project, demo3 FHIR generate example. We've got a shared library there that's got within it the FHIR resources. And then the message flow itself is very straightforward this time. We're simply going to send in an HTTP input. That could be any HTTP input. And then ultimately, we're going to send out the FHIR resource. And as you can see here, the top level ESQL, it's all very straightforward. It's just a set of commented out calls to each one of the different resources that were options within the pattern. And as the comment says inside here, you uncomment one of these lines before deploying in order to create this example. So we could uncomment here allergy intolerance as our example. We can then look at how that's then being invoked. So that call statement there is going off. It's invoking this SQL that I've just opened. And as you can see, the right-hand side of all of these expressions are set to some hard-coded values built on top of the examples that are on the FHIR website. So if you don't like these examples, you would simply come in here and you'd change the right-hand side of some of these expressions to be relevant for your particular scenario. So if you were receiving data from another system, you could quite easily edit this code, but at least half of the job is done for you here because we've got the ability to do that straight off the bat and have those structures set up correctly for you. So we can deploy those flows down. And then we can execute them. So in this particular case, let's try out an example using curl. So this is going to fire in an HTTP post into the input port for that particular flow. And we're going to send in some data to that FHIR generate example. And the data can be, as I say, anything you like. So this is just going to be anything to see the input. And you can see that suddenly a massive data comes back. This is the FHIR resource that's been returned to us. So this again is relevant JSON. It's for allergy intolerance. Rather than dig into the details of that one, we should just know, how this could work. So that's one particular example. If we were to then go back to the flow, for example, I could comment out that particular call statement and choose any of them in here. I think as a lover of Douglas Adams, normally in these demos, I go for the number 42 because it's the answer for the universe. If I go to line 42 here, I could uncomment that and just choose device definition. If this was live, I'd just get an example from the audience. Any one of you could pick any of these, and you can see how quick we can change it. We simply do the redeploy there and then send through the same data, but this time, of course, we're no longer going to be using allergy intolerance. So if we just return to the curl prompt here, this time we send in anything, and we should be getting a device definition back instead. So there's the example with device definition. So very straightforward, but it just gives you the idea of how we've provided these libraries of code to very quickly create FHIR resources without you needing to do any further work. The next one is going to be FHIR validate. So this is going to be our opportunity to show off the FHIR validate node, and we have a pattern that goes alongside that, which again has various directories being used for input and output data. So we're going to drive this from file inputs and file outputs. There's a large amount of text here basically telling you on what the validate options are. We're actually working on something right now to take those validate options even further to enable us for bespoke profiles. So if anybody's interested in specific profiles, then we also have that capability arriving very, very soon. So here we are in the pattern. We're going to generate an instance. We have an input directory, and this is going to receive any file that's put into this temp directory, FHIR validation input. And then if we copy that out, we're going to then use a very similar path for the output parameters. There's several different options here. One that could be a valid FHIR resource. The second one is an invalid. And then the third one, there might be some form of exception hit within the flow as well. So we have an exception handler that's provided with a bespoke bit of Java that's generated for this pattern as well. Here are the validation options. So I can choose to use FHIR profiles if I like. I can also ignore unknown elements if I want to. Those are the Boolean settings. I can translate directly to the validation settings on the node itself. So very quick, fly through there, click generate. Got some background noise in the call. If somebody's drinking from a straw, please go on mute. And there we go. We have the application generated. We have the message. Just opening that up here, and you can see the various input directories and output directories have been referred onto the nodes themselves. So in this particular case, we've chosen to promote the input directories to the flow level. So this is the input directory, so everything's in one place. If we look at the FHIR validate node, then those basic properties have also gone up to the flow level. And then within the two branches coming off that node, we see how we handle the valid and the invalid pieces of data, depending on which branch they've gone down. Now, another good thing here is that we actually also provide example data to pass through these flows. So we're going to deploy that one down, and then we've got some examples that are both valid and invalid that we can fire through. Again, that's deployed relatively quickly. There it goes, successful. And I think the way that we head next is to copy and paste those pieces of test data that are available within those FHIR test messages, which we haven't yet played with. We've got JSON examples here and XML examples. And you'll notice with the style of the files that we've got defined here, the style of the file names, some of these are just straightforward dash example, and some are examples with errors, and some are examples with warnings. So we can choose any one of those to copy and paste and play through. So we're going to try out one of these examples. Why not pick the first one just because it's the most accessible? So this is going to take an example of an account, pass that into the input directory. And I think this one's a success one, so we should expect this to succeed and come out down into the valid folder. So within FHIR validation, if we go into a valid, we can see that the JSON has just been passed through there successfully. So that's as you might expect, same JSON output that we got input, it's just been validated. And then if we pick one that's got an example with errors, we should see that that's treated slightly differently. We should see that we then get some feedback about what those errors are. In the case of one that's in error, invalid, what we basically get out is both the original test data that we passed in addition to a separate file that describes what those errors were. So when we navigate into the invalid directory here, you can see that we have with errors is the name of the actual original input file. And then we also have the one beneath that with the extra extension, errors and warnings.json, and that tells you what the actual problem or problems were with that particular input. So that concludes our demonstrations for today. So all that remains to be said is if you have any queries or questions about App Connect for Healthcare, then please don't hesitate to get in touch. Bye for now.